have used the term called partition coefficient. And even while talking about the ADME, like molecular weight was important because we said small molecules diffuse rapidly. Then when you take into consideration the acidity, the basic nature, then the hydrogen donor number or hydrogen acceptor number are important. So all these things you can consider that we need to consider by developing our some models like QSR. So QSR is just for example, I was telling you that is one of the method, but actually when we are talking about the entire drug design and discovery, there are so many different methods. So as to how you relevance related to the molecular descriptor, I was giving example of QSR. Okay. Today we'll try to understand the QSR in more detail and what are other things are required for doing this kind of modeling so that you can find out the best possible drug. I will tell you the some things and even I will show you one research paper where you can understand the things in more detail. Okay. So here in the title it is written drug discovery and drug design. I said some similar concepts are also useful for your material design purpose also. When you are talking about drug design, here you can see there is this term and then there is drug discovery also. So you should consider there is at least some slight difference should be there in the two terms. Now when we are talking about drug discovery, means this should be actually considered that when we are doing some kind of screening. So from the databases, we are identifying the best possible drug. But then the drug design can be somewhat related to the same topic, or it can be even more, it can be made even more sophisticated term. Like if you identify that some particular compound, you know that that is the best possible compound. So how you can modify that compound after identifying the best compound, how you can modify that particular compound by adding suitable functional groups or something based on some other information you know. So you are actually modifying even the best possible compound what you have found from your earlier method. So you are basically added some other functional groups to it. So this can be considered as something like you are instead of just discovery, you are doing the designing also. Okay. So I said all these things we are basically doing the virtual screening. If you go into the detail of virtual screening, actually this is somewhat equivalent to an experimental technique. Experimentally also people try to do the same thing. They try to estimate the properties of various compounds. From these, they do some initial screening. So that is called as high throughput screening. So many times for the drug design purposes, you might have seen that several compounds together, like more than 100 compounds can be tested together, but still you can consider the virtual screening approach is somewhat which is like having lower cost and you can do even effective screening for so many of the compounds. So if you broadly want to classify the virtual screening technique, it can be categorized into two main methods. Okay. The first method, it is the ligand based method, and the another method, it is the structure based method. From the name you can get some idea. So what is this ligand based method? So if you see whatever I'm talking about, the QSAR method, so this actually belongs to the category of ligand based method. Similarly, there are other things like similarity search method, which we are going to learn later, or pharmacophore modeling. So these things belongs to the ligand based drug design or virtual screening. The other method, it is called as structure-based drug design. So one of the major method that we are going to discuss is molecular docking related to this. So from the name you can consider, like when we are saying that we are going to use this ligand-based drug design approach like QSAR. So in this case, you can consider that you do not have any information related to the targets. Then this particular time you can consider that QSAR methods are useful, means you do not know which particular receptor in your body is actually controlling the function for which the particular disease is occurring. So something will be done by trial and errors. You do not have any information about the targets. So some other features you have to figure out so that you can have at least some guesses like which are the good compounds. Like I always give example of this curcumin turmeric that which are having the good antiseptic properties. So these people know from the literature. So somewhere like if you even if you don't have the idea like what is exactly controlling that inflammation or whatever it is treating. So, but you know actually some known ligands for that. Ligands means again the pharmaceutical drug or compound whatever you are trying to screen. So from those compounds you will try to identify some similar compounds and you will try to identify which of the compound is having the best possible activity. Okay, so this you can consider when you have no structural information of targets. So if you see the other method, which is your structured based drug design. So in this case, you can consider that the structure of the target molecule you already know. Like for example, for the AIDS, you know that HIV1 protease is something which is responsible. So then you are not going to go and do the blind studies. You are going to have some definite studies where you are going to directly work onto the target and you are going to act your ligand molecules as the hits onto this particular target. So there you have these methods called as molecular docking. Okay. So we are going to start with this QSR method for which I already gave you some explanation. But to just go into more detail, these are the ligand-based drug design method in which you need to have some preliminary knowledge of the other molecules which are already active against the target. Means you do not know the structure of the target, but you already have some idea. Like for example, like the curcumin, you already know it has some antiseptic properties. Okay. So what might be done using these information, even you can create a model of some biological target. I said biological target, you do not have any information about the structure, but whatever these active compounds that you figure out. So based on the structure of the active compound, you might be able to design some pseudo structure of the target, some pseudo structure of this receptor molecule. And again, uh, like they say, you can create a structure based on what is binding to it, and again this pseudo structure, the what you have made as the assumption, this can be used to make even new molecules can bind to these kind of structures, and you can find out even the more better structure than this. So you can consider in the ligand-based drug design, you do not have the information of the structure, but based on the ligand information which are active, you can create a pseudo structure. What we are going to learn in this particular thing, we are not going to deal with any model of any target or something. We are just going to rely on the information of the active ligands, and based on that, we are going to create the model so that we can come to know even better ligand molecules. So exactly when we are going to do the QSR, here in this particular slide, the example is given, like what is the need of this QSR, why you should perform that. So suppose even if you just take example of a simple benzene ring, and you try to utilize 10 different groups on these benzene rings on the carbon atom number 1, 2, 3, and 4, whatever you choose. And if you want to do this permutation combination, so just for this one single benzene ring, there are 10,000 compounds that can arise. Okay, if you are just altering the 10 different functional groups. So how to find the needle in the haystack, means how to find out the best possible compound for your um, particular study. So you have this option, synthesize and test all the combination. Like in the lab, you will go and all these 10,000 compounds you are going to synthesize and do all the studies with them. Okay. So this we said this is not possible. This you cannot do. You cannot synthesize all the compounds and you cannot actually do the study with that. So the idea here is you synthesize a small number, just a small number. I said maybe some 5 to 10 molecules. You calculate their descriptors and you measure their biological activities. Okay, this is what we are going to do in the QSR. So I hope till now you might have got some idea what is the biological activity. It can be a good effect, it can be an adverse effect, but this we are going to know in terms of some number. Some number you can consider as Y, and this can be the function of some of the properties, like what you are saying, partition coefficient, molecular weight, or any other compound. So these are the descriptors. So somewhere earlier for QSAR we have say, read the sentence that you can understand it properly, that the accuracy of your QSAR model, it is dependent on which molecular descriptors you are choosing. Maybe some of the molecular descriptors are not at all uh, that much important for your activity molecule, so that you can skip from your model. But the descriptor like partition coefficient should be considered in your model, so that, because hydrophobicity is one of the thing which is always important in case of binding, so those kind of descriptors should come into picture. Okay. And second thing was said in terms of QSR model about the accuracy along with the descriptors, the experimental data should be also accurate. Okay, it depends on the quality of the experimental data. So experimental data, what we are needing, we are going to need it for few compounds. So I said for compound number 8, 9 and 10, or to whatever number of compounds you want to measure, you can find out the activity value properly. I hope just this is the last time I'm explaining about this QSR. Just know this, what we are exactly going to do. Experimentally, we can do the testing for a small number, right? So this small number of compounds we have already tested. We do not have any information about the target or receptor. We just know some of the active compounds. Maybe for whatever compounds we are trying, some of them might be very active, like based on if you consider if the number is positive and high, maybe they are more active. So compound number 4 is the most active one, whereas compound number 7 is the least active, or you can say it is inactive. Okay, so this is the information you are having from your experimental study. Okay, about activity. Now these are the descriptor, like for example hydrophobicity or molar refractivity. This is the values of hydrophobicity for the different compounds you have measured. Now these also consider that these values have also came from the experimental studies. Okay, all the both the activity and the molecular descriptors that you are interested, they have came from the experimental studies. Now these molecular descriptors, if you know the structure, you can calculate on the computer. Even though suppose if you do only have the information about the experimental activity value, you can still calculate the molecular descriptor using the computers also. Okay, but right now consider that everything is experimental. Now what you are going to do in this method, compound number, there are new compounds. Now new compounds, new structure will be there. So this for new structure, you don't know what is the activity value, so you cannot say anything about whether that compound is good or not. So you know, like if the activity value is somewhere between 1 to 1.42, so this can be considered as the good compound, or if it is even higher than 1.42, then you can say I have found even a better compound than what was actually known by the experimental study. So then you have came up with the QSR model like this, and for compound number 8, using the computer you can predict hydrophobicity and molar refractivity values, and these, using this you are going to predict the activity value which was unknown. So suppose if you get the value of 1.36 or something, so you will say okay, I have got some compound which is having the value reasonably good. If the value is coming for compound number 8 as minus 0.07 or something, you will say maybe this compound is not active, so I am not going to use that. For compound number 10, 1.9, so you will say even I have found out the best possible compound. So this is the way of screening. So this is what in QSR we are going to do. So I said you are going to consider small number. Experimentally you can predict the activity, and using QSR you are going to predict the activity for the rest of the compound. So this is what you do in the QSR modeling. So QSR modeling, I have always given you the example of y is equal to something, some simple model, like y is equal to a0 some constant, a1 x. Suppose this is the molecular descriptor, or if you want to make it more complex, a2 x2. So you can consider somewhat similar this models looks like. So your activity value is given in some number, whereas this constants and then this partition coefficient will be given in some way. So this is one of the model you can consider where the activity value is dependent on all these different factors like p, the partition coefficient, sigma, and other constants are there. Okay, so this is what we want to ultimately develop from our data. So now, till now, what do you know? I said you should feel the power that all of you can represent any structure on the computer. Different examples I have given. So you can create any of this structure using the smile string, or you can download the file from any modeling software or protein data bank, and then you can play with it. So if you want to predict if you want to do this QSR modeling, what you are going to need, the why you always need to figure it out from the model, but it is going to be dependent on the descriptor values. So descriptor value you should be able to calculate, right? And for that you will need to input the structure of your compounds, of your ligands, into some software which will calculate the molecular descriptor for you. Once you know the molecular descriptor, so if you already have some activity values from the experimental data, so you can come up with the model, and this model you can use it for finding the activity for value of the new compounds. Okay, so we are going to deal with some techniques like regression I mentioned. So we are going to deal with we are going to see linear regression, multiple linear regression, polynomial regression, and we are going to see how these using the method how we can predict the values of the y, and how we can get more and more accurate model. So there will be some correlation coefficients that also we will need to understand, so that we can decide whether whatever model we have created using our molecular descriptor, whether they are good or not. Okay, so I hope you have got the idea about this QSR. Okay, any questions so far? Okay, just a minute, I will share something. Okay, all of you can see this paper. Can someone reply?
Yes, sir.
Yes, sir.
So just see this research paper, like this is one of the simplest study you can consider that people do, and they try to publish papers related to the drug design stuff. So as you can see in the title, they have mentioned QSAR study on the antibacterial activity of some sulfur drugs. Okay. Now the other details we won't go into much. Just consider that uh, some sulfur-based compounds are there, and for which people are trying to identify the antibacterial activity. Now, if you read this in detail, in this particular study, they have carried out this QSAR using some distance-based topological indices. Okay, in this paper, they have considered some molecular descriptor which are distance-based topological indices. Any distance-based topological indices do you remember that I explained last time? There was something called as binary index, right, for N-butane and isobutane. I have given you the example how it can be calculated. So they have used here the topological indices. Uh, so if you see this study, what they have done, they have used the sulfur drugs which are called as sulfonamide, and they say this is they are well established in pharmaceutical uh, chemistry and for drug design. So these class of compounds, they are having antibacterial properties. Also, they are having some other inhibitory properties. They are anti-cancerous also and anti-inflammatory also. Okay. So if you see this particular structure, this is the general structure they have given for the sulfonamide. Okay, so you can see in all these six different compounds they have studied in this work, and these particular six compounds, if you see till this point, the structure is same. Only this R group, the functional group is different. So different functional group it is coming into picture, it is going to have a different effect on the antibacterial activity. Okay, so from compound number they have called as S1, S2, S3 to S6. Okay, now for all these six compounds they are used this QSAR using this distance based topological indices. but they have seen the antibacterial activity for these three particular bacteria. The bacteria they have considered as E. coli, K. pneumoniae, and B. subtilis. Okay, so all these six compounds they actually used, and they have tried to identify what are the activity value. So this I will go into more detail later. Actually, based on this paper, I want to give you assignment number 2 and assignment number 3, where you should actually be able to represent these six compounds on the computer, and you should be able to figure out their molecular descriptors. That will be assignment number 2. And in the assignment number 3, I will be asking you to develop the QSAR model using the values here, so that I will explain in more detail later. Just right now have the idea that six compounds are there, and for these six compounds they were tried on these three different bacteria, E. coli, K. pneumoniae, and B. subtilis. And you can see here, like for compound number 1, 2, 3 is missing, 4, 5, 6. Okay, and you can see some value as average. Okay, this is zone of inhibition. So this you can consider as some kind of activity values for the five compounds. Earlier in the slide I mentioned to you, right? The same thing we are doing here. Uh, we said synthesize a small number. So you can consider that experimentally they have synthesized those six compounds, and they have measured their biological activities already. So here if you compare it with the paper, so those six compounds what I have mentioned, they have already found out the activity value for the six compound. So maybe the compound number S3, it is not active against E. coli, so they directly removed that data from here. Similarly, K. pneumoniae, you can see 3, 4, and 6 are missing, so they are not active. Okay, but these are the activity value. So this experimental activity value, what you can do, you can create some model based on these, based on the molecular descriptor. So for all the six compounds, they have evaluated some topological indices, some value of descriptors they have estimated. Like for example, this W I had already explained to you. This is the Wiener index. So for each and every compound, some value of Wiener index you can get based on the structure. Like here 536, it can vary to 722, which particular compound you are taking. So what is your work when you are going to do the actual QSR? You relate all these topological indices with the experimental activity value. So if you try to relate this, so different uh, numbers you will come to know, but this I will again explain in detail later on. Just understand this particular equation, that the antibacterial activity against E. coli, this has been given by this particular equation. So you consider this activity value Y is equal to some constant A0 plus another constant A1 into Wiener index. This was your molecular descriptor, minus again some constant into SZ. This is another sum of the molecular descriptor. So this is the model has been developed using the activity value and molecular descriptor. And for this model you can have so many correlation coefficient you can identify, which can talk about how much accurate your model is compared to the experimental data, right? Whatever experimental values you have found out, you should be able to tell the accuracy how much your data it is actually creating the model with what accuracy. So some number that will be there which is going to represent that thing. So slowly I will like next time when I will give you the detail of the assignment, I will just explain these things in short again. But for doing this assignment, what you have to do, just a minute. Share. Uh, is this slide visible? Not. Just a minute. Is this slide visible? The download.
Yes, sir.
So I said all those six compounds you have, But to relate it with the experimental activity value, which is already given in the research paper, you need to estimate the properties or molecular descriptors. So you need to have some molecular descriptors. So we are going to use this paddle descriptor software. You can see here PADEL descriptor. This is the name of the software. So if you go to this particular website, you have to download the software from this link. Now, when I'm saying there are, see, actually two options are given. Uh, they are mentioned here at this place, but don't use this link. Use this. Same thing I have asked you last time also for Open Babel. I think 3-4 students whoever like contacted me, I had seen that there was a button called download, and on that I had made this cross mark and I said you download a version 2.4.0, you click there and download. So most of like whoever downloaded the recent version, I think they had faced some issues because this I had already verified that this doesn't give any error. So again I'm saying you go to those slides, whoever are facing any error, download the correct version of Open Babel because recent software might be having certain things untested, so use the proper version. So Chimera, I think it is not giving any issue, even though your structure might be looking wrong in Chimera, but Chimera is not having problem. Your Open Babel, the recent version, sometimes is creating the structure in the wrong way when you are generating the 3D coordinates. So I'm again suggesting that is 2.4.0. You go back to the slide properly, see and click there and download. So here also, please don't download anything from here. This whenever I tested, I feel there should be some issue or something. I'm saying just this is like tested. So do the downloading from here because later on again some issues might come up. Okay, so download from here. Once you download, it will be you don't have to install anything, just that whatever software you are going to download, that file, keep it in a proper folder and do this. If you are having the WinZip kind of compression software, I think most of the people will use this. So you have to right click and do this, only do extraction, extract to paddle descriptor. So this new folder will be created, okay, paddle dash descriptor. Again, I'm saying you don't have to install anything. So once you double click onto this paddle descriptor, you can see 5 files. Now, one error that many of you will get if you don't have the correct like Java properly downloaded on the computer. So this paddle descriptor, inside the paddle descriptor folder, there will be another file called as paddle descriptor where you have to actually double click and this will be there you can do the calculation, but this will not open if the Java is not installed or maybe whatever the recent version is needed. It will show you simply without Java, like some unknown files or with the extension .j or something. So make sure that Java is downloaded and then only this coffee curve kind of symbol will curve. Then only we should double click on that. Otherwise, we should consider that it is not going to work. Like the problem is with the Java. So download the proper version of it. That will be the thing. Okay, I think today I will just stop here. Uh, if you have any question or anything related to assignment or anything, just ask me. Next time I will show you how to use this software and then later on I will give you the assignment based on those 6 compounds.